pixelation action within this design research is concerned with the loss of material or the changing of its priority. It is done by switching media through scanning, photographing, or the reduction of pixels within an image through a program such as Photoshop. Within the competition test within this design research, Pixelate was also used. It was used on a sketch of a jetty, and it appeared to draw out what we already perhaps had in the back of our heads and made it somehow more prominent. The degradation process and the switching reveals new material and new information. In this example, the copydex becomes more prominent, and as the pixels are reduced, becomes more line-like and changes the visual impact of the drawing. Suddenly you think the copydex lines mean something. This meaning is explored within the space between the two blocks. Suddenly it goes from being an open space to a closed space. What at first seemed to be an accident in using copydex to mark out lines suddenly are brought back into relevance by the pixelation process. During this test, introduce a new view has been taken as introduce a new media and sees the switching of a media when a block is reached. In this instance, the test is performed on a housing project. The project starts by drawing a grid along with some orthographic views, exploring plans and elevations before switching to a CAD environment to start drawing the plan up. This then moves on to a 3D environment where the plans can be modelled into a three-dimensional form. The block occurs when we start to examine the elevations. It's unsure what to do at this point. So the new view or new media is introduced. In this case, a model of the envelope is created. It is scored and folded to sort of examine new possible openings. This is then scanned using an iPad using 123D Catch, which allows photographs to be made into a 3D model via photogrammetry. The process involves uploading the pictures to a server. It then comes back as a model. The model can be exported to a program . In this instance, it is exported to Rhino, where the mesh is then examined before introducing the original model. The 123D catch model is imported into Rhino. And then the SketchUp model is brought in alongside it. The SketchUp model is scaled to match the 123D catch model and aligned. The introduction of the second model to the initial model suggested new elevation possibilities. Zoom is one of 6 tools within Leap. In this instance, it is being used at a master plan level. During this process, a block plan is drawn first of all in AutoCAD. After a short time, the user encounters a creative block and is unable to see past drawing this plan. The user moves to an environment with a laptop, a data projector and an overhead projector to perform the zoom leap action. The overhead projector is used to project grids of varying density over the top of the data projector image. During test, the zoom action has proved useful on details. It can also be used as a zoom out tool where the user pulls back from the subject matter. In this example, the user is rotating the grid to align it with the data projector image. By changing the density of the grid, the user is zooming in and out of the drawing. Both positive and negative grids are used, changing the priority between the overhead projected image and the data projected image. The user starts to draw over the grids and a new layout starts to appear. During this process, the user is zooming between the scale of the map and the scale of the grid, and in doing so interpolating a new space. The sketch on the wall is then used as a trace for a 3D modelling package. The new blocks are formed and then extruded to explore massing possibilities. Before returning back to the plan view, the grid is reimposed. And then a switching process between the context of the map and the new form is done to understand how the relationship between these two new spaces in the grid might work. The rotate action within the leap toolset is used in this instance on a small housing scheme. The project starts by rotating the site and examining possible layouts. A standard housing module is then copied across the site. The block is reached once the site is filled and it is unclear how to get away from the rigid geometry. The rotate tool starts with rotating the entire site over the top of the original site. The center point of the rotation is key here. Excess units are removed to create a more plausible layout. A second rotate is applied to an individual dwelling where the upper floors are rotated. Because of the component geometry of the unit, all of the dwellings rotate simultaneously. The result of rotate is a much more free-flowing development that hints at a way that this housing development could be developed to be more organic. Cut up is one of the 6 leap actions. It is inspired by the Dadaist. In this example, it is being used on a community scheme redevelopment. The project starts with removing the existing development and then sketching out a massing option for a new scheme. A preliminary massing option is established, but it is somehow unsatisfactory and leads the user to use the cut-up technique to develop it. The cut-up starts with drawing a random grid within the software package, duplicating it and rotating it across the site. This forms the lines from which the user can start to cut up the drawing. Once the grid is in position, it is exported to Photoshop and then printed out. The cutting could take place within this software, but in this instance it is performed by hand. In this variant of the cut-up technique, the user must decide which grid lines to cut along. The cut-up slices are turned over and a number is written on the back of each. A website which is capable of randomizing numbers is used to create a random sequence to reorder the cuttings. The reordered cuttings are sellotaped and turned over. A backing plan is placed under the cuttings and then they are trimmed. A sheet of acetate is placed over the cuttings and the backing plan, and a new layout is traced through using the lines from both. It is up to the user to decipher which lines to use. The layout is then scanned back into the computer and reinserted into the digital model for tracing over. In this instance, the result of the cut-up techniques seems to have worked. It has produced a far more sophisticated option in terms of contextual response. Color adjust is one of 6 actions within the LEAP test. Within this test, it is used to examine the reconfiguration of an existing facade. The facade is exported from a 3D modelling package into a 2D modelling package. Once inside of the 2D modelling package, a series of layers are created and assigned varying line weights and colours. The facade is masked with a hatch box. Areas of the elevation are selected at random and coloured with varying layers. This process subverts conventions of line weights and colour. In doing so, it is hoped that new material will appear. Finally, the background hatch is also coloured. The facade is inverted within Photoshop and then taken back into a 3D environment where forms are sketched over the highlighted colours. The output of Colour Adjust hints at how the facade could be developed further.